So, all right, the first test that we took had to deal with transformations. This is right when we came back from break. We worked on transformations. So write the quadratic equations under these specific transformations. Here they give you the parent function. Okay, and then we have to transform them. Here, I'll write it down for you just in case you don't have it written down. Y equals a x minus h squared plus k. So we're just trying to figure out what's a, what's h, and what's k, and plug it in. So here on the first one, if I have a reflection over the x-axis, a vertical stretch of 4, and a translation to the right 2. What's a in that situation? -4, good. The negative because of the reflection, the 4 because of the stretch. What's h going to be? It is going to be 2 because I'm going to the right 2. But remember, we're not going to see a 2 because of the negative in the 4. Once I plug it into the formula, that 2 is going to become negative. And then what's k? There's no mention of a k. K is vertical. Translations is no mention of it. So when I plug in these values into the formula, I get -4, x minus 2, and don't forget the squared. And since there is no k, we don't need to put a plus in it. Can somebody do number 2 for me? Raise your hand. Somebody not named Ann, preferably. Hmm? Yeah, sure. It's just substitution, so.
Y equals 1/2 x minus 4 squared.
Nice. So I got my a here is going to be 1/2. My h is going to be 4, and my k is 8. If you're not sure how I got those, let me know. So y equals, you can also write f of x is equal to. Since they wrote it as y equals, I'm going to leave it as y equals 1/2 x minus 4. Don't forget the square. Plus 8. Okay. Somebody not named Nakai can give me number 3. Go ahead, Caleb. So when we identify A, H, and K, my A here is just -1 because it's only a reflection, and my K is 6, there is no H. When there is no H, what else is there none of? There's no parentheses, good. So y equals -x squared down, oh, I'm sorry, and you know what, I put 6, I meant to put -6. It is -6. And then somebody who's not a basketball superstar that's still left, tell me what number 4 is going to be. Okay, yeah, you gotta say the parentheses, but yeah. So 6, 2. When A is 1, you still need the parentheses because there's an H. So this would just be y equals parentheses. This would be a -6. So when I write it on the inside, it's x plus 6 squared, and then up 2 means plus 2. Any questions so far? The next 4 are just backwards. Instead of you writing the function, they give you the function and then you write the like before they gave us the transformation, then we wrote the function. Now they give us the function and we write the transformations. It's still going to depend on A, H, and K. Even though you might think of this as being a wasted step, I would do it just to kind of organize your thoughts. Here, A is 1/2, H is -1, K is 0. So when I have a 1/2 for A, what does that do? Compression, vertical compression of, okay. Any other transformations? Yeah, you can say horizontal translation, but I know other teachers allow you to just say translation, so that's fine, translation, but you have to say left one. Shobi, do number 6 for me. First give me A, H, and K, Shobi. Okay, that's A, good. Good? Yeah, H is 4, good. Okay. So what does that mean then?
Right.
Yep, I'm gonna go. Remember that horizontal starts with H. So when you have an H, that's 4, horizontal, left and right. But even before that, let's just go in order. Don't be afraid of A. Come on. A is negative. So what does that mean when A is negative? Ingrid, what does it mean when A is negative? Hmm? No. Marmy knows. X-axis reflection. Yeah. X-axis reflection. Okay. And now that because the 3 is negative, Ingrid, what does that also mean? What you said before. What did you say before? Oh yes. Vertical stretch. Stretch of 4, and then as Shobi said, sorry, not a 4, 3. 3. And then as Shobi said, translation, right 4. Okay. For Brandon. Brandon, do 7 for me. Let's start off with A, H, and K. A is what? It is not. It is 1, yes. 0. Good. Excellent. So you got the easy one there. What are the transformations there? Good. Once I saw that other teachers weren't forcing you to use the word vertical, that's fine. You can just put translation of. It's the only one. Okay. And then Jason, you'll finish things off. Number 8. What's A there? It is. What's H? And what's K? Okay. So this is the second time in the last couple minutes that we have an A of -3. So that's gonna do the exact same thing it did the last time. Can you remember what it did last time? Good. The x-axis reflection. And then before that, come on, let's go in order. Go ahead, Martha, help him out. Yeah, we are, but let's just finish up A. Yeah, Jada. Vertical stretch of 3. That's the same thing we did the last time. And then go ahead, Martha. What was the last thing you were gonna say? Oh, or it would down -5 is redundant. You would just say translate down 5. Fax machine. Okay. Convert the following into standard form. What do we know about standard form? So here we're still dealing with quadratics, but remember there were three. Well, better yet, let's do this. What were the three forms of a quadratic function? Standard, intercept, which we also called factored form, intercept form, okay, and vertex form. So if I want to convert this into standard form, what do I need to do? Okay, yeah, exactly. Yeah. Just the same way I say factored and intercept. Think of standard as being simplest form. They both start with S, simplest. So no parentheses. Now Nakai said FOIL, which I agree. That's what I'm going to do first. But you also do have the option of distributing. And the thing is, you can only multiply 2 at a time. But I'm going to teach you to do what he did, which is to leave the 2 on the outside and just FOIL first. X squared minus 4x plus 3x minus 12. Then I'm going to combine like terms, which gives me negative x minus 12. And then I'll distribute the 2. I like leaving the distributing to the end. Let's take the dessert. See if you guys can do number 10. Give me that in standard form. Now, by the way, don't forget that technically the f of x has to go there. I just didn't write it. Thank you. Raise your hand when you got it. What'd you get, Nakai? Yeah. So structurally, this is going to be identical to number 9, even though you don't see a number on the outside. There is a number on the outside. It's a -1. And just like on number 9, I'm going to choose. Not that you have to, but I'm going to choose to leave it until the end. I'm going to just FOIL the 2 parentheses first. So x squared minus 5x plus 6x minus 30. Keep the negative on the outside. X squared plus x minus 30. And then the last thing would be, what happens when you distribute a -1? What's the easiest way to describe what happens to the contents of the parentheses when you distribute a negative? Just all the signs change, yep. So now we'll get negative x squared minus x plus 30. Don't forget, you have to still name the function which was f of x. Okay, how about intercept form? What's another word for intercept form? Factored form. So what do you think you have to do if you're going to write something in intercept form? You have to factor. Now, technically, just to be clear, in order to factor, you first need to be in standard form. Luckily, both of these 11 and 12 are both in standard form. So I know factoring, that's a big monkey wrench there. That's not as easy as it sounds, but it requires a lot. What would you do first to factor number 11? Greatest common factor, very good. They all have a 2 in common. I can factor it out, which leaves me x squared minus 3x minus 4. Okay, then this is, if you remember, when I first start teaching the kids and I teach them the two column table, and A is 1 and B is -3 and C is -4. So then the question is, what 2 numbers multiply to give you -4 that add up to -3? what two numbers, when I multiply those two numbers, I get -4, but when I add them, I get -3. -4 and +1. It doesn't matter the order, but you have to end up with a 2 on the outside, x plus 1, and then x minus 4. The 4 has to be negative, the 1 has to be positive. If you ever had the time and you were inclined to do so, the same stuff, if you understood what we did up here, you should be able to get your answer and simplify this and get back to where you started. For number 9, we were given intercept form. Here, look, just for fun. Why do they call it intercept form? That's the x-intercept. That's where it's going to cross the x-axis. Where is number 9 going to cross the x-axis? Since it's already an intercept form, I can tell you just by looking at it. Gotta change the sign. -3 and +4. Yeah, because remember, you'd have to make each one of these equal to 0 and solve. So to make these equal to 0, this would have to be a -3, or this would have to be a +4. Where would number 10 touch the x-axis? -6 or +5. Well, now that I've converted this to intercept form, show me where is this? Where's number 11 going to touch the x-axis if you were asked? +4 and -1. This number 12 is easier because there's no greatest common factor, so it's just a question of what two numbers multiply to give you -8 and add up to 2. +4, -2, yes. So f of x is equal to x plus 4 and x minus 2. Sam, now that this is an intercept form, if I were to ask you where this is going to cross the x-axis, what would you tell me? Where is this function here going to cross the x-axis? This will be the 4th time we do this now. Go ahead, Kiara. Yeah, -4, +2. Change these signs. Yeah. Because +4 times -2 gives you -8, and when you add them, it gives you +2. If you go back in the notes, I used to teach you how to do this with a 2-column table where you would put -8 and 2, and you'd be like, oh, what are all the numbers that multiply? When the first column is negative and the second column is positive, that's a small negative and a big positive. So -1, +8, -2, +4. Which one of these add up to 2? -2 and +4. Do you remember that? Okay. Now the last one's vertex form, which vertex form, is what I showed you up there. That's vertex form, what you have at the top. It's what we use for transformations. So for vertex form, you need to identify A, H, and K. You're going to want to have it in standard form also. So for both intercept form and vertex form, you want to start in standard. Both 13 and 14 are in standard, so that's good. So all we're trying to do here is turn A, B, C into A, H, and K. What's my A for number 13? It is -1. What's B? 8. What's C? 10. The good news is that the A carries over. Whatever the A is in standard is the same A in vertex. Then you learn the formula. Who remembers the formula for H? -B over 2A. Very good. So the 8 for B becomes negative over 2 times -1. That's going to be -8 over -2, which is +4. Then you might remember the fun little game that we played to find K to make it easier. I showed you synthetic substitution, -1, 8, 10. It's up to you if you want to do it this way. I think it's quicker. So Okay, H is 4. K ends up being 26. If you plugged in a 4 for x, you get the same thing, but I'd be worried about this negative. If you guys do it through substitution, there's a good chance you make a mistake with that negative. Now that I know A, H, and K, it's just substituting like I did up at the top. They called it f of x, so I'll leave it called f of x. And that would be, since A is -1, it's just a negative, then the parentheses. H was 4, so x minus 4 squared, and then plus 26, that's K. See if you can do 14 for me. You got it on number 14 already? You're stuck like Chuck. Well, let's see if somebody else can get it. Why are you stuck? Yeah, what are you getting for H? No. No fraction. Anybody think they're close or no? You got it already in? Let's see, what'd you get? That could be right. Let's see. So, and did anybody get anything different? What would you get? I didn't do the K in my head, but I believe it's going to be a fraction. So if I have to guess, I'm going to guess hands right. Because you didn't get a fraction for K? I'm trying to, I didn't finish it in my head, but from what I started in my head, it looked like there was going to be a fraction, but let's see. There was once in her life in the past when Anna was wrong. It's only happened once, but you never know. Negative b, so you got to change the b to a positive 6 over 2 times 2, which is 6 over 4, which is 3 over 2. So Caleb, you wouldn't have left it at 6 over 4, you took 3 over 2. If you're really frustrated and you just say, oh man, I don't know what to do, fine, then change it to 1.5. I advise you not to because decimals are a slippery slope. You never know when you're going to get to a point where now you're going to have to round. At least with fractions, you don't have to round. But it's up to you. And the synthetic substitution can still be done with fractions. You don't need to be afraid. So let's see, if I drop a 2, negative 3 over 2 times 2 is positive 3 over 2 times 2 is 3. Okay, then here I had a negative 3. Negative 3 times 3 over 2 is negative 9 over 2. And then, negative 3 plus negative 9 over 2. I'm doing it in my head. I can do it on the paper if you want, but in my head, I'm getting negative 15 over 2. I'm guessing you guys wouldn't do it in your head, but you can do it on the calculator. So, f of x ends up being 2, stay the same, x minus 3 over 2 squared minus 15 over 2. That was a tough one. Sam got it though. Any questions there? Martha? No questions for you? Let's see how much. We probably won't finish the second page, but we can at least get started. Ooh, fun word problems. After t seconds, a ball tossed in the air from the ground level reaches a height, blah, blah, blah. Who cares? Because they give you the function, so you don't have to model it. What is the height of the ball after 3 seconds? That's right, it's 3 seconds. The point is, if the 3 is seconds, where am I going to put the 3 in for? Yeah, and I'm going to assume that you know how to substitute, so just for fun, I'll show you here the synthetic substitution works. But you got to put it in standard form. So the negative 16 would come first, the 144 would come second, and then since there's no constant, that would be a 0 at the end. You don't have to do it that way. I'm guessing most of you would have just plugged in the 3. Probably easier that way. But I like to live dangerously. Negative 48, 96, 27, 288. I'm doing it in my head. 288. Did I do that right? So, and we're measuring height in feet. So 288 feet. If you don't understand how I did it with synthetic, just plug in the 3. 3 squared is 9. 144 times 3. 250. 352? No, 452. Is it 144 times 3? None of the above? No, I'm way off there. 432? Okay. Whatever. Minus 16 times 9. So minus 126, I think. What's the maximum height of the ball? Okay, so what do I need to know in order to find a maximum? What is that word? What did I tell you to associate maximum and minimum with? The vertex, good. And if I want the maximum height, that means I need the k of the vertex specifically. So this is in standard form. So I'm gonna have to get this. We already know that a is negative 16, b is 144, and c is 0. So I'm gonna have to get h first. And actually, that's, you know what? Perfect. Let's get the best use of space. I can already tell from C that C is gonna. That's what C is gonna ask me for. It's gonna ask me for how long it took to reach the maximum. So that's H. So I'm gonna just find it here. So H is equal to negative 144 over 2 times negative 16, which is negative 144 over negative 32. Is it 4? Or it's a decimal? Yeah. What is it? Decimal? 4.5. Since this is a measurement, like Caleb's like, whoa, man, what? How come last time I wanted to use a decimal, you didn't let me use a decimal? Well, it's not that I didn't let you, but it wasn't as conducive to what we were trying to do. But since this is a measurement, decimals are fair game here. So we'll go with 4.5. That actually ends up being the answer for C. And we're measuring in seconds, so 4.5 seconds. At 4.5 seconds, it'll reach the highest point. Then to figure out where it's at, I can do the exact same thing I did up here, but instead of plugging in a 3, I can just plug in a 4.5. 4.5, negative 16, 144, 0. So negative 16 times 4.5. Don't tell me. Negative 72. Negative 72. And that's 72. Oh no. 36, 288, and 36, 294, 314, 324, 324. 324 feet. After how many seconds will the ball hit the ground? Oh, this is a good one. If I want to see How high is a ball when it hits the ground? At 0. So we're going to make this equal to 0, which means now you have to remember how to solve a quadratic equation. But this is pretty simple because you can do this by factoring out a common factor. The greatest common factor here is 16. So you would say 0 is equal to, bring out the 16, 16 divided, how many was 16 divided by 144? 8 maybe? Decimal? 144 divided by 16. 9? Oh, it's 9. So, oh, and I'm sorry, I should have brought in a t also. They also have a t in common. So then that would be 9 minus t. I divided both by 16t. If 16t equals 0 and you divide by 16, that means that t is equal to 0. That's just showing you that the first time the ball was off the ground was when no time had passed by. The ball started on the ground. Is it a ball? Yeah, it is a ball. The next one I would solve if 9 minus t is equal to 0. Minus 9 minus 9, negative t is equal to negative 9. So when I multiply by negative 1, t is equal to 9. So answer the question for me. How long before it hits the ground? The ball was on the ground at 0 seconds and at 9 seconds. Once it was launched, it took 9 seconds to hit. And we'll stop it there. So remind me that tomorrow we'll take it up on where it says test 2. Question? You have a question for me, Anne? No? Yeah. Can you add C? There is no C there. C is 0.
No.
Uh-huh. Oh, yeah, okay, yeah, that's true. That might even be easier, yes. So what he's arguing is, maybe he doesn't even know he's arguing that because a parabola is symmetric. He knows that if it takes 4.5 to get to the top, it'll take another 4.5 to land. So it'll take 9 seconds. All right, we'll finish up tomorrow. Something you might want to do